Hi everyone, and a massive welcome to AXA Arctic Live. It's fantastic to have you all with us. My name's Jamie, and we're going to be working through this live investigation into sea level rise together. Very shortly we'll be joined by the amazing Dr. James Lee from the University of Liverpool, who will be joining us to talk all about ice. But before that, some very important housekeeping points. There is a chat app beside the video. You can also get it up on a second screen. Do use that chat app for sending questions and comments to us. It's great to see so many. You can upvote questions as well. So if you see a question you really want answered, upvote that. Try not to upvote your own question. And it's also really helpful to avoid duplicating questions that have already been asked. We've got a couple of polls coming up for you today as well, and they will appear in the chat app on the poll tab. If for any reason you need technical support, then you will find on each page of the Encounter Edu website a chat icon in the bottom right hand corner, green chat icon. Click on that and you will be connected to the support team who will try and help you with whatever is going wrong. So without further ado, we've got some amazing shout outs to those great classes joining us. We have a shout out to Year 4 at Sandridge School in Hertfordshire. Hi everyone there. We have hello to Victor Scott Primary P6 students, and they're all the way in Bermuda in Buoy. Fantastic to have you all with us. We have hello from Longcott and Fernham Primary School. Hi guys. Hello to Dove's class, Year 5 at St Michael's and Sunning Hill. Wonderful to have you with us. We have Eastcombe Primary School in Stroud, Gloucestershire, who've been learning all about climate change. Great, and looking forward to your questions later. A big hello. Hi, St Giles. Hope you're enjoying your live lesson from the Arctic, and that's love from Mrs. Taylor. So hi to everyone at St Giles. Big shout out to Year 6 at Penthorpe School in Rudgwick, the Grange Primary School in Bootle, Liverpool, and the amazing Amaya, who is homeschooling. And last, but by no means least, we have Primary 6, Wood Park Primary, and they're very glad to be here. Very shortly, we are going to be asking you to grab your ice and get involved in a live investigation together with us in the Arctic. But before we get into all of that, I think we just might be able to join James, who's going to help us understand ice a bit better. James, are you coming through?
Hi, Jamie. Really good to see you. Really good to be here as well. Also, hello to everyone at fantastic. You guys are here.
Brilliant. James, thank you so much for joining us. We've got stacks to get through today. We may even have a chance to have a look around. But we're going to start off this live lesson with trying to understand ice a little bit better. Up here, if I look out, it's basically all white. Looking out, I've got white on the snow, I've got white on the mountains, I've got even some white in the sea. Is it all the same, or are there different types of ice that I'm seeing out here?
Oh, you'll be seeing lots of different. So there'll be the snow on the ground. There'll be the ice in the glaciers. In the ocean, you'll be seeing sea ice. And also in the oceans, you'll be seeing icebergs, which have broken off the glaciers as well.
So, I mean, how is it? So you've mentioned things there. How are sea ice, glacier ice, and icebergs different from each other?
So starting off with sea ice. Sea ice is simply just seawater that's frozen. It's basically when the surface of the ocean cools down, normally to around about -2. So this freezing point of ocean water is slightly lower than the normal water. So then it starts to freeze, it starts to form a very thin layer of ice, and then that gradually gets thicker and thicker and thicker as it merges together until you form essentially a sheet of ice covering the ocean. For the glacier ice, this is quite different. It's formed in a quite different way. So glacier ice is basically a big accumulation of snowfall. So snowfall over tens, hundreds, even thousands of years that accumulates. It builds up. As it builds up, then it presses down and compresses the ice, compresses the snow into solid ice. So you can sometimes see little air bubbles, which are little time capsules of what the atmosphere was like hundreds of thousands of years ago. And then that ice then moves through the glacier. And then if the glacier ends in the ocean, then that ice breaks off to form an iceberg. So the iceberg was once part of a glacier as well.
That's really helped me, and I imagine helped the classes watching to understand where those different types of ice have come from and how they're formed. One of the things I see in the media a lot is about the amount of ice changing, that we're losing ice, but sometimes there's more ice. Does the amount of ice change naturally through the year? Certainly, I can see sort of seasonal changes being up here.
Oh, definitely, yeah. So just as when you look out of the window and you see in the summer you've got leaves on the trees, and in the winter you don't. You have similar cycles that go on with sea ice, especially. Um, in the winter, obviously it's very cold up in the Arctic. And during that time, the amount of sea ice expands, it grows, it covers a much bigger area. And then when everything warms up in the summer, then during that time, the ice melts, it reduces in its area. And as it reduces in the area, then you get basically more ocean as well. And then the whole cycle starts again as you go into the following winter.
When we hear about sort of ice loss in the news, are we talking about this natural variation, or is there something different that's happening?
No, so it's quite different when we're talking about it over longer time periods. So time periods that are span over multiple years or decades or centuries. Over these longer periods of time, we can see whether year on year these things are expanding or contracting, or so basically getting bigger or smaller. And what we're seeing at the moment, which is quite worrying, is that we're getting reductions in Arctic sea ice, and then also reductions in the amount of ice in some of the polar ice sheets, so like Greenland and Antarctica as well. And those have very different effects as well in terms of what that loss actually means for the planet.
I think we've got, first of all, just in a little bit more detail, what's happening to Arctic sea ice, and I know that the Greenland's your speciality, so maybe we could have that afterwards.
Yeah, sure. So Arctic sea ice we've had really good observations of Arctic sea ice from around about the late 70s. And that's where we've been able to map what sea ice has been doing on the entire scale of the Arctic Ocean. And what we've seen since then is a huge, huge reduction in the minimum extent of the Arctic sea ice. So it's lost a huge area, around about the size of the state of Alaska in the States. So it's just over 1 million square kilometers of ice that has been lost. And that has really important implications for the overall temperature the overall temperature of the atmosphere as well. So if you have a nice shiny surface that's ice and that is capable of reflecting a lot of the sun's energy, then that's quite good for the climate. But if you replace that with a really dark ocean, which is what's happening, then the dark ocean absorbs a lot of the sun's energy and then basically warms everything up even more. So it's this vicious cycle of sea ice then causing more warming, which causes less sea ice as well, unfortunately.
Is it the same in Greenland, or does Greenland sort of behave differently? This ice sheet we have up in the Arctic.
So Greenland is slightly different. So Greenland is an ice sheet. It's one of these, so it's made up of glacier ice rather than sea ice. So there's around about 7.5 meters worth of sea level change wrapped up in the Greenland ice sheet. And you'll be glad to hear that that's not going to be going anywhere very quickly. But nevertheless, the amount of ice that has been lost from Greenland, or is being lost from Greenland, is increasing, or has increased over the past 20 years. And just over the past 20 years, the amount of ice that's been lost from Greenland has been able to raise global sea level by 14 millimeters, so 1.4 centimeters, which doesn't sound like a lot. But if you think about it, it's been able to raise the entire global oceans by 1.4 centimeters. And the worrying thing is about what Greenland, or what things like Greenland and Antarctica are going to do in the future and how rapidly they're going to change.
That's been amazing. What we're going to do now is we're going to try and put some of these ideas into practice. If you've been listening carefully to what James has been saying, you'll probably be able to answer the polls. For this activity, what you will need in your classrooms, in either individually or small groups, you will need 2 containers. You will need 2 cans, either a food can or a drinks can. They really need to be full so they stay sunk. You will need access to some water. Okay. You will also need a marker pen or some way of marking the level of your sea and your mini oceans. And I think we've got a short clip of how to get your ice for this live investigation. So if we just get that, and so just remember that you also need an iceberg, and this is where you go and get your iceberg from. Hi, we're on the beach in the Ålesund, up on Svalbard. The research station's just over here. Very shortly, I'll be coming back to do a live lesson for you guys all about sea level rise and thinking about the different types of ice that we have up in the Arctic. Now, one thing we'll be talking about are icebergs, and you can see a couple behind me, just beached here, a bit larger one just further out. To do this investigation, you are going to need ice in the classroom. Now, I'm very lucky, there's a bit of iceberg down at my feet. If you don't have any icebergs near you, it's okay to use ice cubes from the freezer. But I'm just going to pick this up. We'll use it in our investigations today, and we'll speak to you very shortly back at the station. Hi, so if you are have your iceberg, you just need to make it into small ice cubes. It is okay if you don't have an iceberg next to you, just don't mind me. I'm just going to get little bits of ice cube off the side here, and then we'll get started. Get these into slightly smaller pieces. I think those are looking pretty okay. And get a large piece off the side here, and a bit smaller. James was saying, about, see if I can find a piece with an air bubble in it. What James was saying is that you get air trapped in it that captures the past. I'll find one as we carry on with this. This is a bit of a grubby iceberg, probably scraping along the bottom. So I'm going to take my gloves off now. Before we start this, well, actually, let's get the poll up. And the poll is really predicting what is going to happen. So we're going to got two mini oceans here. So for one ocean, we're going to have, I'm going to write on here, SI for sea ice. And the other one is going to be Greenland. So remember, the sea ice is in the sea. I'll just need to put a few bits more in here. Find my ice axe and make this smaller. So in here I've got sea ice, and then James is talking about huge amounts of ice in Greenland. So that's our big Greenland ice sheet. I'm going to fill up the water in here to the same level. I'll get the writing there and the mark there. I'm just going to talk through the setup, so don't worry if you haven't set up completely yet. I'll talk through the setup, make sure that's all put away. So, James was previously talking to you about the different types of ice. On this side, we have an ocean in here. We have Greenland. And on top of Greenland, we have an ice sheet, land ice. And we're going to see what happens as the land ice melts, see what happens to our sea level rise. In this example, we've again got land, perhaps not much ice sheet on Svalbard where we are, few glaciers, but sea ice. So we're going to see what happens when all the sea ice melts and see what happens to the sea level rise here. See if I can fit in one tiny bit more, bit of sea ice, just to give us a bit more. Just to get it up to the level. Just over. I have to draw another line. So what I'm going to do is, because it is very, very, very cold today here, is I'm going to take these into a warmer part of the station where we are. And while I'm doing that, we are going to think about two things. James is going to introduce you to some of the work he's been doing in Greenland and a bit more about the glacial environment. But what I'd love is for you to think about some predictions. We're going to poll up for you and be thinking about this poll. Now, this is about predicting, and you have 4 choices to be making. What do you think will happen? Will the sea level rise, so melting sea ice and melting land ice, will both cause sea level rise? Whether only melting sea ice will cause sea level rise, only melting land ice will cause sea level rise, or that melting ice actually has no impact on sea level rise at all. Have a think about what might happen, your prediction. Then make sure your mini oceans are somewhere nice and warm. And I will be back with you shortly, but I'm going to hand over to James to tell you a little bit more about his work in Greenland.
Hi again, everyone. I'm a geologist at the University of Liverpool. So what that basically means is that I have the amazing job of looking at these things behind me. And then I primarily look at glaciers that end in the ocean and produce icebergs, as well as these are some of the glaciers that actually contribute the most towards global sea level change. So in Greenland, where I work, there's they contribute around about 50% of all loss from the Greenland ice sheet. And the main way in which they do that is through breaking off icebergs. And I've already seen a few questions in the chat about sort of how many icebergs are there and how many are breaking off the ice sheets. And as you can see from the photo behind me, so this was taken in summer. There are literally millions and millions and millions. So it's almost uncountable the amount of icebergs that are breaking off. But the thing is with icebergs is that you don't always have icebergs of the same size. So this glacier behind me, so this is my favorite glacier, this is my second favorite glacier. These produce really sort of small to medium-sized icebergs. So again, these are, well, I say small to medium-sized, they're still quite big. When I've stood next to some of them out in the field, they've towered over me by several meters. And these are, because they're very small, they can melt very fast. So because as they melt, they get smaller, the amount of surface area that's exposed to the ocean it gets larger and larger. It means that they can melt really fast. You have other glaciers in Greenland and Antarctica that produce truly huge icebergs. So these are icebergs that are the size of entire counties, if not sometimes countries. And these break apart much more slowly, they melt much more slowly, and they can also travel much longer distances as well, out into the open ocean. And then they can cause risks to things like shipping. So you may have heard of the Titanic disaster in the early 1900s. That was caused by one of these big icebergs that broke off from Greenland, and there's still a risk now. So as Arctic sea ice starts to melt, there's going to be a lot more shipping traffic going through the Arctic. So actually understanding how big the icebergs are, not just how many break off from Greenland, is going to be really important to understanding what that risk to shipping is going to be. So it's one of the many things that we're looking at here in Liverpool to then sort of try and understand what the impacts on global sea level change are going to be, but also what's the broader impacts as well.
I caught the tail end of that with a fascinating discussion on icebergs. We will obviously need to spend much longer talking and sharing your experiences with students at another time, unfortunately. because we have a good 30 or more questions come through from classes watching. So perhaps I can put some of them to you now. Test you on your knowledge of all things ice and cold.
Fantastic. Looking forward to
Uh,
it.
the first question is from St Giles on the Heath, and you've touched on this, but will either the Arctic or Antarctic ice sheets, ice caps, ever completely melt? And if so, how quickly or when might that happen?
Yeah, so this slightly comes back to telling the difference between ice sheets and sea ice as well. So the Arctic ice cap that covers the Arctic Ocean, that's all sea ice. So it's not actually very thick. So in its thickest bits, it's maybe about 30 meters thick, and in its thinnest bits, it's maybe a meter, meter and a half, if that. And at the moment, we think that there's the potential for the Arctic Ocean to be entirely ice-free by, at the earliest, even 2035, so only 13 years away. But a lot depends on what we're going to do in terms of greenhouse gas emissions. So if we limit greenhouse gas emissions, then we can postpone that until 2060, 2070, or maybe it might not even happen at all. If we look at the ice sheets, however, these are really, really thick bodies of ice. So the Greenland ice sheet is over 2,500 meters thick in some places. And this is why it holds around about 7.5 meters worth of sea level change. And that's not all going to melt overnight, but over the next 100 years, or by 2100, it could have contributed around about a meter to global sea level change. So it's still a huge amount that can be contributed to sea level. And that's not even including Antarctica, which includes about 65 meters worth of sea level change. So there's lots and lots of ice, and some of it will go more fast than others. The Arctic sea ice won't change sea level. Greenland and Antarctica will.
And do scientists put dates on when Antarctica will be ice free? I mean, has it been ice free in the sort of geological past?
So the last time Antarctica was ice-free was about 35 million years ago. So long, long, long time ago. There's probably no one who's saying that Antarctica will become entirely ice-free. With the Greenland ice sheet, the last time it was ice-free was maybe around about 2.5, 3 million years ago. But during, so in the more recent past, use the word recent slightly advisedly there, around about 120,000 years ago, the Greenland ice sheet was much, much smaller than it is today. So most of southern Greenland didn't have an ice sheet. And we know that because when we've drilled ice cores down through that 2.5 kilometers worth of ice, right down to the bottom, when we've looked at the soil underneath, we found pine needles and pollen, and we can do radiocarbon dating on those materials. And it's said that 125,000 years ago, there was no ice. And what we're getting to now, in terms of our climate at the moment, is we're starting to get our climate being warmer than it was 125,000 years ago. So question is, how fast does that happen? It may be 100, 200, 300 years before we start to see major shrinking of the ice sheet. But in the meantime, there's still a lot of ice there. There's still a lot of ice to be lost. And as I said before, by 2100, we think that our best estimate of what sea level is going to be is it's going to be over a meter higher than it is today.
James, thank you so much. We've got some a quick fire round just for you, a few great questions, but we've got Wood Park Primary School. Will the sea levels ever go down?
There's a very complicated answer to that, in practical terms, not in our lifetimes. So globally, yeah. So
Would
yeah,
that
I'll
would
leave
that
it at
happen with
that.
another ice age, for instance?
Yeah, so if there was another ice age, then global sea levels would go down. So during the last ice age, global sea level was about 120 meters lower than it is now. There was a big ice sheet over the UK, over most of Northern Europe, over most of North America as well, and that locked up 120 meters worth of sea level within it. And that only disappeared about 20,000 years ago. The changes that happen, they happen on what seem like long timescales. But if you think about it in terms of sort of when everyone listening to this grows up, then you'll be, so everyone here will be, well, me included, will be living with the effects of that as well.
Um, from St Michael's Church of England Primary School, have you ever been attacked by an Arctic animal or bird?
Um, Not directly attacked, but I've been slightly harassed by a sea eagle before. So sea eagles are like these big birds of prey. And when I say big, I mean really big. They stand about 1 meter tall and their wingspan can be about 2.5 meters wide. And we were walking to one of our field sites and we must have got a little bit too close to its nest. And these two sea eagles started circling around us and dive bombing us as well. So they didn't thankfully make contact with us because they would have really done some damage. But that's the closest that have been to being attacked by anything.
What sounds like an amazing and quite scary experience at the same time.
Oh, completely. I was not not terribly happy with having these 2.5 meter wingspan birds of prey coming at me.
The next question is from Amaya, and she is wondering how will rising sea levels affect life in the ocean, so sea creatures.
Yeah, so it's a really important thing and a really important impact that ice loss has. So as you melt the ice, it makes the seawater less salty, and then that and certain fish and certain sea animals and things like algae as well. They depend on the seawater being a particular level of saltiness. If that happens, then where they live in the ocean will have to change and they'll have to move. And the other aspect of it is that when, especially from Greenland and also Antarctica as well, when you get meltwater coming off the ice sheets, they carry a huge amount of sediment within them. And in those sediments are lots and lots of nutrients. So those nutrients can actually cause big expansions and big explosions of algal life, so little microscopic algae in the ocean, and that in turn can create food for fish and other animals as well.
Big mix, something like dumping a whole bunch of fertilizer in the sea. We've got a next question coming up from Harry at Hyam Ferris Junior School, and this may, I know this is slightly outside your scientific field, your field of research. We've got this is a question, in fact, from Shana in year 6. How is the melting ice affecting polar bears?
Yeah, so that's a really important thing as well. So polar bears rely on sea ice for hunting and basically keeping themselves fed. So as you reduce the amount of sea ice, then that reduces the polar bear habitat as well. So it puts them at risk. polar bears have actually been moving onto land quite a lot more frequently. And Jamie might be able to say of things that have been happening in Svalbard. But then also in the Russian Arctic as well, there's been instances of 30, 40, 50 polar bears descending on the very small towns and villages that are there, and trying to go through the rubbish just to try and find some food. So as you reduce the sea ice, you're changing the behavior of the polar bears, and you're also limiting the resources that they actually have to survive as well, unfortunately.
Yeah, James, certainly. So the polar bears, as James was saying, like hunting on the sea ice for seals, they are coming over to where there's more nesting areas for wildfowl, so duck and geese, and that providing their food in the summer. Still not great. The sort of normal food, seal providing a lot more energy and nutrition. Um, this is a brilliant question from Penelope at Cumnor School, and would like to know what percentage of the world is ice.
So it's about 10%. That includes the Greenland ice sheets, Antarctic ice sheets, the Arctic ice cap, and then also the Antarctic ice cap, sea ice as well, and glaciers around the world. Obviously, as things warm up, then that number is going to be decreasing as well. But at the moment, to the best of my knowledge, at least, it's around about 10%.
Brilliant. Thank you very much, James. And thank you for the question. Nightingale class, and you've touched on this, and this is a very sort of open question, but how thick is the ice, and does ice thickness matter? That's my bit on the end.
Yeah, so the thickness of the ice varies quite a lot. So here for the glaciers behind me, this glacier just here, at the front, it's around about 200 meters thick. This one just here, the ice is around about 80 meters thick. So at the edge, it really varies, and it depends on the shape of the bedrock underneath the ice sheet. However, if we go right up to the middle, right up to the top of the Greenland ice sheet, then it's around about 2.5 kilometers thick, so around about 2,500 meters. If we go down to Antarctica, then there's parts of Antarctica that are nearly 4 kilometers thick, so really, really significant distances. Significant thicknesses of ice. And then if we look at sea ice, that's totally different. Sea ice is much, much thinner. So sea ice that has been around for a few years, it's been moving around the Arctic or the Antarctic oceans. That's had chance to build up, it's had chance to bunch together and become thicker, and that can be anywhere up to around about 30 meters thick. Ice that's only been formed for 1 year can be around about a meter and a half thick. And the worrying thing that we're seeing, especially in the Arctic, is that we're seeing a reduction in this multi-year sea ice, this thick sea ice, and it's being replaced by this single-year sea ice. So not only is the area of Arctic sea ice becoming smaller, but it's also becoming thinner as well. And that means that as things warm up, it can melt relatively more quickly, and we can lose more area of the Arctic sea ice cover.
James, thank you so much. I'm going to have to leave you to go through your amazing glaciology and iceberg talk for a little bit longer. I'm going to go to the laundry room cupboard to see how much melting has happened and see whether our predictions. We'll look at your predictions shortly, and then see how those translate over into what we can observe. So I'm going to hand back to you, James.
Thanks for that. So I've talked a lot about what we think is going to happen to the Greenland ice sheet in the future. And normally, so one of the questions that I get asked about that is, how do we know? And one of the ways in which we do that is by using computer models that use our understanding of how ice flows, the physics, the climatology, so what the climate is going to do. But then we also need to test the models as well. We need to make sure that they work. And one of the ways in which we do this is by comparing the results of the models to past behavior. So I've done quite a bit of work on this in southwest Greenland for these two glaciers. And one of the things that you'll be able to see from the photo behind me is that if you look just here, you'll see that there's a grey bit, and then there's a darker bit as well. So the light grey bit, that marks where the glacier once was. So that's around about 300 meters of elevation change. And then if we trace these lines all the way out, then where the glacier is today, 250 years ago, the glacier was 23 kilometers further advanced. So that's about 15 miles further advanced. So if like the world's best marathon runners were trying to run that distance, it would take them about 2 hours to try and run the distance that these glaciers have retreated. And what we do is then we look at where the glacier has been in the past, we compare it to the results of the models, and if they match, great, we know that the models are working. If they don't match, then it means that we need to improve them. And some of the stuff that we've been doing very recently, actually, is showing or demonstrating that the models that we have the climate predictions, the sea level change predictions based off of, is that they actually work, that we have been able to show that the physics in the models actually matches up with what we observe in the real world too. So unfortunately, that gives us confidence. So fortunately or unfortunately, depending on your perspective, it gives us confidence that these projections of 1 meter's worth of sea level change are actually physically accurate as well.
James, thank you so much. And thank you also for explaining how this science works, where all these and how these predictions appear in our media and everything else. So Ellie, you've got, I think, some of the poll data coming through from the prediction. How did our wonderful young scientists predict what would happen? What kind of sort of percentage choices did they make?
75% said that the melting sea ice and melting land ice will cause sea level rise.
Okay.
8% said that only melting the sea ice would cause sea level rise. 17% said melting land ice would cause sea level rise.
Okay, so we've got 3/4 of you going. So both types of ice are going to cause sea level rise, and then some of you thinking it's only sea ice or only land ice. I've just luckily got a very nice toasty laundry room, but we're just going to come and see what might have happened on this side. I'm going to arrange them in a way that you want them forward. Both of them.
No, that's perfect.
Perfect. Good. So we have on this side we have our Greenland ice sheet, which you can see has come down to a tiny wee bit on top. And on this side, most of our sea ice has melted. And I'm just going to point round in the front. You can see the sea ice, the sea level has stayed pretty well the same. And then we've got this slight rise where our land ice has melted. Going back to what James was saying, is that the sea ice is where the sea just freezes and thaws, so it's actually the sea freezing. So the melting sea ice does not have an impact on sea level rise, but as James was saying, when it's on the land, like in Greenland or in Antarctica, melting ice there will drive sea level rise. With, I think James was saying, was it 7.5 meters of sea level rise contained in Greenland, and 1 meter predicted by the end of the century?
That's correct, yeah.
Right, so what we can see from this small little investigation is how we can understand different types of ice and the impacts their melting might have. There are, of course, big impacts from melting sea ice, and we'll be talking more about those tomorrow in our Caring for the Arctic live lesson. Very sadly, we've got to the end of our time. James, thank you so much for being part of Arctic Live. It's been absolutely fantastic to have you with us and to have your experience, your wisdom, and your insight into sea level rise and polar ice in general. So thank you very much from us. And thank you to all the students who've been watching. So until the next time, it's goodbye from Arctic Live. Bye bye.